Good afternoon and welcome to Carlam Cymru Revision Sessions. This session will focus on Electronics A-Level and will be presented by Mr Jonathan Williams from e-sgol Maes y Gwendraeth. The session will last around 45 minutes where the teacher will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your question during the session. The session will be recorded with a recording and any relevant resource uploaded to the e-sgol website in the Carlam Cymru area. Diolch.
Okay, croeso. Okay, welcome all. If you're watching live, neu os chi'n watch ar YouTube. I recommend if you're on YouTube that you can pause at any time. This session today, this is part 2, which is to do with timing circuits, involves a lot of calculations. Okay, a lot o gwaith cyfrifon hwn. So os ych chi yn watchan ar YouTube, newch yn siŵr bod cyfrifannes gyda chi, you have a calculator. I will be putting the equations on, but then I'll be pausing, and then I might ask you, have a go on your calculator in order to work this out, and then you can check it against my answer. As I said, there are a lot of calculations, and these are the type of calculations where you need practice on a calculator. Mae defnyddio cyfrifiannell mwyn gweithio pethau mas yn hanfodol o bwysig ac yn ennill lot o marciau i chi am y pethau fi'n mynd i fod yn wneud heddi. Felly, bant ni. Right, timing circuits. Eto, fi'n mynd i just atgoffa chi, okay, mae gyda chi lot o hafaliadau fan hyn sydd ddim yn cael ei roi i chi, fel o'n i'n gweud V equals IR. Dyw hwnna ddim o bwys i ni heddi. Beth fi'n mynd i dangos i chi sydd yn bwysig a bod chi'n gwybod ble mae nhw yn data sheets chi. Okay, yn gyntaf i gyd, bydd data sheet yn lan amser chi'n mewn i'r arholiad. Cofiwch mae hawl gyda chi ysgrifennu arno fe. Gyntaf yw yr arholiad hyn ar y top, T equals RC. Hwna yw y time constant. Okay, cy'n gyfer unrhyw beth i wneud gyda capacitors cynhwysydd gyda gwrthydd. Felly, pidwch bod yn ofon ysgrifennu, chi'n bod time constant drws nesau hwnna yn yr arholiad. Chi'n gwybod ble mae fe. Hwna'r time constant y cysoni'n amser. Hefyd, beth sydd gyda ni yw'r hafaliadau hyn i gyd fan hyn. Mae'r rhain i gyd yn cael ei defnyddio mewn unrhyw beth i wneud gyda amseru. Anything to do with timing circuits. Now, these can get confusing. So, fel I fi'n cofio no, this is how I remember it. For a capacitor in timing circuits, charge, discharge, charge, discharge. So, I see a lot of people writing down the wrong equation when it comes to capacitor networks and timing. They've chosen the wrong equation. So to put it on, if you remember that, charge, discharge, they're in order as we go. This is for the Schmidt trigger when you're doing an unstable. Okay, the F equals 1 over RC. Mae gyda ni'r T equals 1.1 RC. Mae'r hafaliad na fyna yn cael ei defnyddio gyfer unrhyw beth sy'n insad. Okay, so anything to do with a monostable, which produces a pulse fel la. Okay, there's your monostable. Wedyn mae'r doi nesaf sydd gyda ni, y TH and the T-low, mae'r hynna i wneud gyda unrhyw beth sydd yn ansefydlog, yn unstable or astable circuit sy'n rhoi pulse in it. Okay, so the TH refers to the high time, a wedyn mae'r T-low gyda ni am yr amser isio, the low time. Wedyn mae dyn ni yr amledd, this is the frequency of the on-off. Gyda'r hafaliad hyn, bydd ni'n dod I enghraifft, yn aml iawn, mae'n rhaid I chi newid y C ar F. Okay? So cross multiplication. So bydd ni'n dod I hwn nes mlaen, ond yn bosib ail ysgrifennu hwnna, you can rewrite it by writing C equals, just cross multiply with the F. Okay, so you have the 1.44 on top, a wedyn bydd yr R1 plus R2, a bydd yr F wedi dod lawr. Okay. A yr un diwetha wedyn, sydd dyn ni'n mynd mark space ratio sydd gyda ni'n mynd. Okay, you've got the T on and the T off, R1 over R2. So mae hwnna I wneud eto gyda fath o gylched sydd yn rhoi inside, the astable one. Right? In order to work out the high time and the low time, and the mark space ratio, how long is it on for, off for, T on, T off. Right? So mae'r hafaliadau yna mynd I fod yn eithriadol o bwysig. They're exceptionally important. You know where they are, and you know which ones they are. Okay? A lot of people will waste time in an exam looking for an equation. Know it, okay? top tip. Right, here we go with the timing circuits. Right, the first one, obviously, we need to remember about a capacitor is how it charges. So a capacitor will charge quickly, right, towards the start, and then it sort of evens off as it gets fully charged. Right, so the equations, we mark them up from the data sheet. So here we go with the charging capacitor. Okay, right, important things for you to remember. A capacitor will always work with a resistor. Mae wastad yn gweithio gyda'r gwrthydd. So beth sydd gyda chi yw T equals R times C. It gives us time constant, and that is so important. Time constant is measured in seconds. Right, other things about the capacitor when it charges up. Okay, the VC is the voltage of the capacitor. The VO is the voltage of the supply that you're using. All right, remember that one. Now it's possible to work out the voltage of a capacitor by using that equation. But we've seen in a minute, there's a handy equation which is not in the data sheets. Okay, dwi ddim na, ond mae'n handy os chi gallu cofio hwn. Mae gyda chi, the time taken to half charge it is 0.69 RC. Right, and hwnna more handy I cofio. So just cofio 0.69 RC, half charge or half discharge as well. And un arall sydd ddim yn cael ei roi, another one which was not given, yw'r 5 RC. So 5 times the time constant is the time given to fully charge. So our amser mae'n ala I gwefru i'r lefel mwyaf posib mae'n gallu wneud, yw 5 RC. They're not there in the data sheets. Okay, please remember them. Hefyd gyda ni, when it's charging up, the time taken to reach a certain voltage. VC is the voltage of the capacitor, and VO is the voltage of the supply. Okay, so it's handy to sort of visualize what happens. So here we go, we've closed the switch. When you have a circuit, you have to be able to realize, is that circuit charging up or is it discharging? Okay, so yn yr achos ydyn ni fan hyn, siwna ni'n cyd y switch sydd dy fi lan fan hyn. Okay, the switch now and keyed, it closes. That gives basically the capacitor ability then to charge up. Okay, mae'r gwrthydd sydd yn fan hyn, that resistor there will control the speed and how long it takes. So the bigger that resistor is, okay, the longer it's going to take to charge up. Okay, which leads us on to an example. Right, typical type of example that they will use maybe in an exam. So os fi'n disgwyl ar hwn, first thing, is it a charge up or is it a discharge? So if fi'n disgwyl, os mae'r switch na yn mynd I cyd, mwyn meddwl, mae'n mynd trwyddo'r gwrthydd and down to the capacitor. So close the switch, that resistor, the current and the voltage are going to basically cause that capacitor there to charge up. So I know it's a charging, okay, circuit. So bit gofyn it'll always do things like ask you the time taken for you to reach a certain voltage. Now then, looking at this one, because I know it's the charge up time, okay, so I'm going to look for the charge equation. So beth ydyn ni'n ysgrifennu, then ni'n put a charge equation loud. Okay, and you get this from your data sheets. Now, can you gweld why using a calculator is going to be so important, because these equations are complicated. Okay, right, so you've quoted your equation to start with. Right, I'm going to substitute the numbers in. So beth byddwn ni'n neud? RC, na ren. Mae'n handy, all right, felly beth byddwn ni'n neud? To prove in Caldain, I will write down RC and I will just work it out, just out of the equation, so it's there because I know I'm going to use it all the time. So RC fi fan hyn bydd a 200k, okay, a fi'n mynd I llosi hwnna gyda 100 microfarads. Okay, I'll pause there. Os chi ar YouTube, work it out. Stewch chi nôl. Okay, byddwn ni hwnna yn gweithio mas I fod RC da fi fan hyn I fod yn 20 seconds. Okay, so fi'n mynd nôl mewn i'r afaliad. I've got my RC, so bydd da fi minus, cofiwch mae minus na, mae'n bwysig. I've got the 20 times A wedyn, mae dy fi'r LN, right, on your calculator, know where that LN button is, okay? You've got two buttons on your calculator. You've got the LN, which is on the far right-hand side on a scientific calculator, and you've got the LOG button, which is next door to it. Make sure you press the right one, okay? So LN, siarad byti. A wedyn mae ni 1 minus, right, the voltage of the capacitor is going to be 6, okay? Because we've head on 6 volts. And VO is the supply voltage, and the supply voltage is 12 volts. Right, plug that into your calculator. Okay, I'll pause there, come back, and guess gwyddoch chi hwnna mas, gewch chi ateb o 13.86. And it's going to be in seconds. Now then, with a lot of waith, now then, it happens, and they like doing this quite often. If you notice, I've got 12 volt supply, and I'm going to be 6 volts capacitor voltage. It's just half. Right? Comes up very often in exam papers that they give you the opportunity, if you can remember it, to use 0.69 RC. So yn lle defnyddio'r hafaliad na I gyd, chi'n gallu, mae hawl da chi, okay, so chi'n cofio'r 0.69 na, i wneud 0.69 times wedyn, cyswlyn amser, so byddwn ni'n bod 0.69, llosi hwnna gyda 20 seconds, bydd hwnna yn rhoi gwmws yr un ateb i chi. Right, a mae'n safio mor gwmynt o amser. Only happens, okay, if it is half the voltage. Okay, calculate the value of V out. Okay, fi'n edrych am rhafaliad. Okay, go to your data sheets, to charge up equation. So, V0, V out, okay, is equal to, sorry, VC. Achos mae V out gyda ni, V out yw voltage y croesydd ei hunan. So mae dynnu VC is equal to V0, supply voltage, 1 minus, then mae E to the power. Nawr ar y cyfrifannes sydd gyda chi to, okay, byddwch chi'n disgwyl i weld mae E to the power button. So af yn arfer ar rhan fwyaf calculators, chi'n neud y shift LN button, a chi'n cael yr E to the power. Eto, you need to practice to put that into the calculator. Okay, giving you the substitution numbers for you to practice. The VO supply is 12. 1 minus E to the power minus, cofiwch y minus na, so chi'n rhaid fi mynd o'r cyfranel, is 30 seconds. A mae dyfu'r cyswlyn amser, and again, that RC. So the RC fi wedi gweithio mas yn barod, okay, it was 20. Okay, pause if you're watching on video. Come back. Os chi'n teipo hwnna mewn yn iawn, fe fyddwch chi'n cael 9.32 volts. Okay, practice, practice, practice. Right, yr un diwethaf fan hyn, time taken to reach 12 volts. Now 12 volts yw'r supply voltage. Okay, so fully charged. Now fan hyn, mae rhaid I chi cofio'r 5 times RC. Okay, dwi ddim ar it. 1 mark amdano fe, so 5 times the 20, a bydda hwnna yn rhoi 100 I chi, 100 seconds. Fully charged. Okay. Okay, discharge. So, gyda discharge equations, eto, look it up in your data sheets. Okay, so you'll see that the equations are slightly different. Okay, so mae dynnu'r voltage of a capacitor eto, supply voltage, E to the power, chi'n dach chi'n gyfarwydd yna, you should get used to it. 0.691 still comes into play, and so does the 5RC hefyd. Okay, and then you've got the time taken to reach a certain voltage. VC, your voltage of capacitor, V0, you supply voltage. Recognition of a circuit, right? But how do you know that this is basically a discharge? Right, so if I'm looking at this circuit, so gyda fi fan hyn, right, this switch at the minute is open. As mae'r switch na ar agor, mae'r capacitor is discharged. Siwrna hwnna, okay, yn mynd I cied, that capacitor there is going to charge up straight away because there's no resistor in the way. Does dim gwrthydd yn y ffordd o gwbl. So mae'r capacitor, mae'r cynhwysydd na mynd I gyrraedd 9 volt yn syth. Nawr, siwrna fi'n agor y switch, beth bydd yn digwydd wedyn, bydd y capacitor wedyn yn dadwefru, will discharge, dadwefru trwyddo hwnna. So, tricky circuit, just i adnabod, right? Once you press that switch, capacitor will charge straight away. When siwrna mae'r switch yna'n cael ei agor, once it gets opened, okay, it will start to discharge. So here we go, on the animation, switch closes, bang, straight lan, there's the charge up. Nawr mae'n cael ei agor, switch gets opened, nawr mae'n dadwefru, gloi ar y dechrau, okay, a wedyn mwy am. Switch i'r clear to fyna, bang, cael ei gwefru straight away, and nawr mae'n dadwefru, it discharges through that resistor. Okay, so recognition of the circuit. In an exam, always think to yourself, right, is this capacitor charged or is it discharged? Then you go for the equations. Okay, so, da ni enghraifft bach fan hyn o un sydd mewn yn y roliad. So what I've got here, switches bach hyn fan hyn, okay, mae'n gweithio chi taw monostable, taw un inside way, right? So I know that this is going to basically create a pulse, okay, on the timing circuit. So beth by'n digwydd, I will press that switch. Once I press that switch, that capacitor is going to charge up straight away to 12 volts. Once it opens, it is then going to discharge, okay, through that 1 mega ohm resistor. Right, so close that, and the voltage of V1 will be 12 volts, but then it is going to discharge. So now we've gwybod beth i'n neud. Question says, determine the time taken for V1 to reach 6 volts. Okay, so chi'n gweld hwn to, okay, it comes up quite often, 6 volts, okay, and I got 12 volts. So mae hawl ddech chi fan hyn, straight mewn gyda'r 0.69 RC. Right, so os byddwn ni'n gweithio mas y cysonion amser, that RC in this case, so I'll be multiplying the 1 mega ohms, multiplied by the 47 microfarads. Just got a video pause there, just multiply those, and if you come back, that will give you 47 seconds. Okay, that's cysonion amser. So 0.69 of 47. Okay, and if you want to work that out, that will give you 32.4. So mae hwnna'n ffordd o wneud yn gloi. Okay, the quick workings, just because that was 6. If that was another value, you would have to use T is equal to minus RC. So it's the discharge equation I'm looking for. Log VC on top, V0 on the bottom. Substitute the numbers in. T equals, right, I've worked out the time constant already. So that was 47. Cyfwch y minus na. Log VC, voltage of the capacitor, okay, to reach 6 volts. So 6 is on top, 12 is on the bottom. Okay, practice. I'll pause there. Get back. Okay, and if you work that out, that will give you 32.6. Okay, then, yeah, there is a little bit of difference always between using the 0.69 and using the big equation. Mae wastad bach one, yeah. Ond i fod honest, mae 32.4, 32.6, dyn nhw ddim yn marco chi lawr achos bod y gwaniaeth. They won't mark you down because of those decimal places being slightly different. Okay. Calculate the value of V1 after a time t. Right, so I know it is basically going to be a discharge. So I look up the discharge equation. Discharge equation is the VC. E to the power of minus T over RC. Substitute in, VO is the supply voltage every time. E to the power. Minus T, I'm using 10 seconds. RC, I have worked out already. You can see why RC comes in time and time again. Well, that'll be the 47. Okay, I'll pause there. Practice it on the calculator, hopefully. And there's your 9.7 volts. Okay, Right, other circuits that so what we talked about there is basically about using a capacitor. Right, so now what we're going to look at is using the 555 monostable to make pulses, okay, and using Schmidt's as well. Right, so in this circuit, just explain how it works, comes up quite often. You will always have a table with thresholds given to you when it comes to timing circuits, and the important one is the 4.5 volts. So when I'm looking at the NOT gates to get everything in, basically if I have 9 volts going in, because it's a NOT gate, you know that's going to be naught. If it drops down to 4.5 volts, then the logic goes high, so it will go to 9 volts. So mae'n bwysig to know your threshold voltage. In an exam, don't panic about some of these values. Okay, right, logic 1 output level is 9. Input impedance, don't worry about that. Okay, it is a data sheet, but you have to pick out the important values. So in explaining the circuit itself, is it a charge or a discharge? Right, well, at the minute, what we've got is that there's a voltage coming down, right? Because that switch there is open at the minute, it says the fridge door is open, that will open. Okay, so when the fridge door in this case is normal, that it's closed, so basically you have current coming down this way. So what will happen is that the capacitor basically is not charged at all. Then what will happen when that opens, pan mae'r switch yn agor, that capacitor is going to charge. So then you sgrifennu and the papur, right? It's a charge up. So I go and choose basically my equations which go with it. Okay, so what will happen, the capacitor will charge up. As it charges up, that's where the threshold is going to kick in. Once it reaches that 4.5 volts, then basically the output of the NOT gate there will change. Okay, so that's the explanation of the circuit itself. So if we're looking at what they're asking, the question, they're asking for the time constant. So straight away, remember that time constant would be the RC. You're looking at the resistor, and you're looking at your capacitor. Okay. Eto, gyda K, just be aware, K stands for kilo. Okay, so that's your 10 to the power of 3. Okay, and your micro for your capacitor, 220, just come up on that's the 220s times 10 to the minus 6, right? All of these units, the kilo, the micro, the pico, they're given again to you in your data sheet. Okay, there's a little table there for you to have a look at. Okay, pause, put that in. And that will give you 165 seconds. Coming to the last bit, okay, determine the time taken for it to reach 4.5, and here we go again, right? There's the 4.5, and I realize the supply voltage is 9, is half. So straight away, easy 2 marks there, use your 0.69 RC. So 0.69 of your 165 would give you 114, basically, seconds, right? If you can't remember that, you have to work out it's a charge up. So use your charge up equation. I won't write it down again. I'll put it in with the numbers itself. So you end up with 165 is your RC log. Oops. And give me 1 minus, it'll be 4.5, which is your VC divided by 9. Okay, if you want to practice that in a calculator, you can pause that, put it in. Okay, come back and you would end up with close to the 114. Okay, dead on, but it doesn't matter. Right, using the 555 recognition. First of all, what they can do in an exam, they could ask you to draw. Maybe they won't ask you to draw the 555, but they could ask you to put in where that resistor and capacitor, okay, are. these leads will have been put in for you already. Beth maen nhw'n gallu neud hefyd yw gofyn I chi am yn licio hwn yw rhoi y gwrthydd a'r switch hyn man in. That little section there, they like asking that one. The reason for it, which is important, very important to actually know, realise, is that a 555 monostable works with a falling edge. So ar hyn o bryd, the voltage at that point there is 9 volts, right? Because that switch is open. Once I close that switch, that point there is now linked to 0. So that 9 volts goes down to 0 volts. So it's a falling edge, right? That falling edge is what triggers a 555 monostable, yr insad, I rhoi a pulse now. Okay, to get that forward, get that pulse coming out, it's got to be a falling edge. So if I just run the simulation on this one. So at the minute, nothing coming out of it. Okay, here comes the pulse, falling edge, it's been triggered. And that is going to stay high for a certain amount of time, and then it comes down. Okay, so there is the monostable. Triggering again. Okay, and it'll be the same pulse. It can be redone again and again and again. Equation, look up your data sheet where the monostable is. There's your T equals 1.1 RC. Right, we look at an equation usage or hon, right, and here is an example where they've given you the monostable and they're asking you basically to fill in the circuit itself. Oops, so there we go with the resistor. Okay, and there's the switch which will trigger it. Okay, so the name and then. Interesting what they've done here, they've asked you to add a relay. Okay, so with a relay, yeah, a relay is basically something that you do have to remember how to draw. The way that you draw a relay is you draw a little resistor, the dotted line going across. That dotted line links to a switch, like so. Right. So what a monostable is commonly used to do, right? It will trigger a pulse, and that will basically, when the relay, there's the relay. That relay, when it gets triggered, will close that switch, and then so you end up with a circuit over here. So relays are things which are used usually to switch on things which have got quite a high voltage. Okay, electronics, we like using really small voltages. Okay, there's 240 volts there, probably coming from mains. So that relay has been used to turn on a light, which is using 240. But the symbol for that relay, yeah, you need to know it. Okay, it does come up quite often. Right, so it's asking us now to work out a resistor value. Okay, so it comes on for 1 minute. So identification, yeah, it's a monostable. Get the equation from your data sheet, look it up. There's your 1.1 RC. Right, you will have to rearrange equations. Right, so in this case, it's asking us for the C. So if I rearrange that equation, the 1.1 R is going to go to the other side. It's the C value. The T has got to be in seconds. Okay, 1 minute. Okay, sorry, it's the R that I want here, so that R is going to be substituted for the C dividend, sorry. Okay, so what I have is the 470 on the bottom, microfarads. 470 is times 10 to the minus 6, so I'm going to pause, you'll put that in your calculator. 116K, okay, or if you have all the numbers, it'd be 116054 ohms. Okay, it's perfectly all right to round up quite a large resistor, okay, to 3 significant figures. Okay, so I'll just go with that equation again. So if T equals 1.1 RC, I wanted the resistor value. Okay, so I'm going to remove the 1.1 C. 1.1 is multiplying, take it to the side, it's going to divide. The C is going to go as well because it's multiplying, goes to the bottom. Okay, so it'll divide. So from there, I can work out my resistor value. Right, using Schmidt triggers, yeah, you will have to draw that. Okay, so learn how to draw a Schmidt trigger. Schmidt's will be covered in the next topic area. So the symbol for a Schmidt trigger, learn that. Know that the capacitor there, and you've got the resistor, and you've got the Schmidt equation, the frequency. So Schmidt's basically triggers, I guess, will give you basically a pulse when that's stable. Okay, and same with the 555. Wiring is different to the monostable. Again, what they could do, they could ask you to add that little section to the 555. Learn basically how to draw the 555 as stable. Equations, we talked about those, they come from your data sheets. Okay, we look at a few examples. One thing that, they could ask you is, what is the advantage of maybe a 555 compared to a Schmidt? With a Schmidt, what you'll have is an equal mark-space ratio. So the high and the low times, okay, will be equal to each other. Now with a 555, you won't ever be able to get a T high and a T low time which are equal to each other. There's your T high, amser uchel ar amser isel gyda ni fyna. Ar amser uchel, amser isel, maen nhw wastod yn mynd I fod yn wahanol. Okay, so the mark-space ratio is always different for 555. Okay, so that is a fact that you do have to remember. Okay, so here is your 555 as stable. Okay, so once it is switched on, so what we've got there is your T high time, there's your TH, and there is your T low. What they like doing is asking things about mark-space ratios as well. So mark is basically the T high. There's your mark, and the low basically is your mark space. So the low time is your space. Okay, here we go. So this is an example which is asking us to calculate a value of mark and space ratio. So equation, go back to your data sheets. Okay, if you have a look at it. So what you have is T on over T off. So mark is the T on time, space is the T off time. Now what is equal to is your R1 plus R2, and that is divided by the R2. Right, you do have to memorize the top resistor is your R1, and the one underneath is R2. Okay, simple enough. So if you substitute the numbers in, you will have the 20Ks. Both of them happen to be 20K in this instance. Okay, ar un gwylod wedyn be the 20K because that is R2. Okay, I'm going to try that on a calculator. Or if you want to use your head. Okay, you always get it down to a mark space ratio of something to 1. So in this case, I got 40 divided by 20. So that will give me a ratio of 2 to 1. If you give an answer of just 2 on its own, because 40 divided by 20 is 2, right? You won't get a mark. Okay, it's always important. Calculate the value mark and space for a stable. Mark is 2 to 1. There's the ratio. Okay, they're always looking for that. And those 2 little dots there, okay, indicate that that is the ratio. Right, and coming to the last bit for today is what we've got is a 555 term again. And this time it's asking us to work out and calculate the value of C. Right, now then, equation, go back to your data sheet. In your data sheet, you will see that for an astable, you have the 1.44 divided by R1, R2. Again, recognize the top resistor is R1, underneath it is the R2, and you have your capacitor. Mae'r hafaliad sy'n cael ei roi I chi, F is your frequency, okay, with which it changes from high to low, high to low. A simple case of with this equation, I've put it there for it, if you need to work out the capacitor, as what they are asking in this question here, it's pretty simple. You just cross multiply the F and the C. Right? So the F takes the place of the C. So what you'd be left with is the 1.44. Got the R1 plus the 2R2. Okay, and the F has come down. So just practice that, okay, in terms of writing the equation down and then being able to rearrange it for your C. Happens quite often. So we're going to work that one out. So I'm just going to substitute the numbers in. So our R1 in this case is the 30k. To be that the R2 is 30k as well. Be careful, be really careful with how you put that one in to a calculator. And the frequency in this case is 1. So I'm just going to put that 1 in because, you know, it could be a different number. So if you want to see where that 1 goes. Right, yeah, when you're putting this one into a calculator, some calculators, if you put in 30,000 and then plus 2 and then multiply by 30, it'll work it out actually incorrectly for you. So what you'd be tempted to do is, are you either, because you can see that is 2 times 30, you know that's going to be 60, so I put in 60k on the bottom in your calculator, or right, I would open up a bracket, close a bracket, so it does that, okay? Yeah, calculator sometimes will add the 2 to the 30k and then multiply by 30 by mistake, so you basically have to separate it out. Okay, so that is definitely one. Practice this one, please, on a calculator. I'll pause. Okay, and then I'll come up. All right, so if you have that one, that should work out to be 1.6 times 10 to the minus 5. And that would be farads. Okay. Handy little button for you on your calculator, if you don't know about it, is the button which has got ENG written on it. All right. Looking at my calculator here on my scientific one, it is above the 8. Now, if you press the ENG button, what it does automatically is turn your number into a scientific format. So you would get basically a number with 10 to the 3, you get number 10 to the 6, 10 to the 9. Also, if you do a shift and press the ENG button, okay, it'll take you and it'll give you, go backwards, then you can end up with a minus 3, minus 6, minus 9. Okay, so sometimes it's handy sometimes. So you've got the 1.6 times 10 to the minus 5. If you press the ENG button on that, that will give you basically 16 times 10 to the minus 6. So you could write your answer as microfarads. Okay, you won't get penalized for obviously for writing that because that is the answer, right? But yeah, get used to it. It does become handy now and again, especially in year 13, right? If you know your microfarads, okay, you can put in 10 times minus 6. The numbers sometimes are easier to put into a calculator. Right, and finally, calculate the mark space ratio. So we've got the mark space ratio again. T on is your T off. Remember, it's going to be a ratio. So what we got is your R1 and your R2. It's in your data sheet. Okay, know where it is. Substitute your resistors in. So we have got 30Ks on the top there. Again, that just happened to be equal at the minute. And you've got the R2, 30K in the bottom. Okay, pause there if you want to type it into your calculator. Okay, so we'll be throwing a mass with it in top and 60 dros the 30. Turn it into a ratio. So rhywbeth I un pob tro. So 60 divided by the 30 gives you a ratio of 2 to 1. Okay, so basically, that's a quick run through on timing circuits. As I said, the important thing I would say in terms of revision, okay, and I'll flick back if I can, right to your start today, was the data sheet, right? Just knowing where the equations are, because it is equation heavy, as you've seen in this revision session, right? Is knowing where those equations, ble mae'r hafaliadau yna ar y taflen chi. right? Just know them. So you're not going to waste time in an exam thinking to yourself, oh, is that the charge? Is that the discharge? So know it. Okay, so just knowing that in the section, charge, discharge, right? It's going to save you time. That time constant, work it out. Okay, when it comes to a question, right? Because it's going to be used time and time again. If you work out your time constant, it's going to save you time putting it into a calculator if you have that number. Okay, the time constant is a beautiful thing if you work it out straight away. And what you got on the bottom there are your equations. Just know there's your monostable, right? There's your T high, there's your T low if you need to work it out for your R stable. That's the R stable frequency equation. There's your mark space ratio, which we reviewed quite a bit in this revision session today. Okay, so thank you for listening. As I said, play it back, pause, practice on your calculator. Okay, diolch yn fawr. Ta-ra.